So just a few reminders. We're on day 2 of 2.2. The quiz is open since yesterday. Today's the last stuff that you're going to learn for it. Remember, I don't want you to get a 0 on it and not do it at all, but I don't want you to just submit it to submit it, okay? So, maybe start working on it if you haven't already. And then Tuesday's a work day in here. You can work on any of your homeworks, like I said before. You can work on watching any of the videos. I will help any of you individually on anything you need. But you can also work on your quiz. So if you want to bring your laptop that day and work together, remember, it's not cheating. You're allowed to work together. You can sit in a group and work on the problems. I don't care, okay? That's what I want you to do. So just think about how you can use Tuesday to best benefit you anytime we have a work day, okay? And Tuesday is going to be a homework check as well, all right? So what we did yesterday was we talked about how arithmetic sequences and linear functions were related, right? And just, you don't need to write this down because it's in your notes, but it's easier for me to kind of write. We learned yesterday that M, and I'm going to use an equal sign, just allow it. I mean, they're not exactly the same, but M and D represent the same information in a sequence as it does in a linear function, right? And does anybody remember, what does A sub O equal? E. Oh my gosh, so many people said it too. Yeah. So we did the sequence language was like A sub n equals A sub 1 plus D n minus 1, right? And then we did algebraic, which was M equals Ms plus B, right? So, and one of the things that, and I think I mentioned it yesterday, but I want to make sure I do again and again and again, is that one of the confusing parts of these lessons and a lot of the things we do in here is all the different variables and names for the same thing and keeping it all straight, okay? We cannot get hung up on the fact that, wait, but my Algebra 1 teacher, my Algebra 2 teacher, my Geometry teacher, Khan Academy, they say slope-intercept form is this. Not that anyone has said that to me. But understand, these mean the same thing. This is a linear variable, x to the first. It's a line. M represents slope. B represents the y-intercept. I can put other letters in there, okay? And that's really the level of understanding what you're working with, not getting freaked out that we used an N instead of Y and X, okay? So that's something I want you guys to kind of work on. And so what we're doing today is talking about geometric sequences and how they have a relationship with exponential functions, okay? So exponential functions, and again, I say this a lot too, is you guys covered exponential functions in Algebra 2. Not that I necessarily think you memorize it all and you just know exactly what an exponential function is. I'm saying that because it should be familiar to you, especially after I go over this. So an exponential function is in this form, y equals a times b to the x, where a is your y-intercept and b is your ratio. So you're going to see in a minute how, just like with the linear functions and arithmetic sequences, exponential functions and geometric sequences are super close together, okay? And our notes are really short, like I said. They're exactly the same as yesterday, like in the same place on the paper, just with different numbers because we're dealing with geometric, but the same directions pretty much. So here we have the beginnings of a table, and we have a graph of an exponential function. So I want you to see how it curves. It's curvy instead of a line, like yesterday we had one that was like this, like a line. And right when you see that, you should be able to say that's geometric. But you can also tell from the table. So here's that variable thing again. This is an n a sub n table. Same as x and y, input, output, right? Lots of different ways of stating the same information, depending on what context we're stating it. Okay? And so yesterday we had to find the common difference and finish the table. Here we need a common ratio. So remember how to find your common ratio. Let's talk about common ratio again. Common ratio is what we're multiplying as we go left to right. Okay? So if we don't know, if I can't look at that and tell what's happening, then I would need to test it going the other direction. So So instead of multiplication, I would divide any two consecutive numbers right to left, and here's two right next to each other. Put in my calculator. So 32 divided by 64, math, enter, enter, 1/2. So my R is 1/2. When you multiply something by 1/2, it divides it in two. That's how we're getting 32. So 64 times 1/2, or make it faster in your calculator, divided by 2, would be 32. And then you can fill in the rest using your calculator or your brain, whatever. Okay, so there's an there's a geometric sequence. Those are the points that are graphed here. Okay, it asks us in part B to find the common ratio. Okay, we already did. It's 1/2. And write an explicit rule. So the explicit rule for geometric functions, remember, it's the same as general rule, general term, is a way to find the nth term. And this is the formula for it. And -1 up there. Okay, so we have the R. We need A sub 1. There it is. And now we can write the formula. Okay, there's our explicit rule. Okay, nothing really earth-shatteringly new there. This is where we say how exponential functions are really similar. Different domain again, okay? It's important that you guys understand with exponential functions and linear functions yesterday, before we talked about sequences, the regular old functions, they are connected. You would connect these dots, okay? And there'd be arrows coming off of our ends because they go on forever. But when it's a sequence, it's just these points, these dots. It's not everything in between. That's the difference between them, okay? But we can write an exponential function that includes these points that would match up right along those points. And like we said, we know the formula. I just gave it to you up above if you want to write it again. What did I keep doing that? So a times b to the x. So we need a and we need b. Now remember I said a is your y-intercept. What does the y-intercept translate to in sequence language? A sub 0, right? Remember, a sub 0 is when x is 0, y is whatever. So it's your y-intercept. There's a lot of different ways you can say it. Oh, I know I just said that, Aaliyah. That's a good point. I'm glad you said that. She said b, because now we're talking about a different b now, right? This is not the slope-intercept b. That's a y-intercept. That's confusing. I never even thought about that. Okay, so different formula, b means something different here. Isn't that fun? A whole alphabet needs the same letter. Okay, so a is really a sub 0 up here. We know how to find that. We've been going backwards in this chart all week. So obviously, when I divide something by 2, meaning multiply it by 1/2, it's getting smaller. So if I'm going to go backwards, it's going to be bigger. So we just do 64 times 2, okay? So that would be 128, right? A sub 0. And b is the same as r. We already found that. And now we can plug it in. I want you to notice one huge difference, though. And again, I'm using weird letters. If you had done it before I wrote it, you put y and x, it's okay. Understand that you might see it different ways, but we should recognize like the rhythm of the equation. Okay? What's the big difference? Big difference between these two that I want to make sure you guys all see. That's it. There's no -1. Okay? Because you're so used to it. You've been writing n-1 500 times this week. So just be careful when we do, and it looks so similar, right? You have a number after the equal sign. You even have the same number in the parentheses. You have the same power, but one has a -1, one doesn't, okay? And that's a common mistake students make. And we're going to do it like 2 more times in the notes. And I'm going to do instead of doing word problems in your notes today, I'm going to do the 2 word problems in your homework with you first, right after the notes, and then you can go back and do all the easier stuff and the rest of the class. So you're going to see it a couple different times, but that's something I want to really point out and make sure you guys notice. Okay? Question before we go on? Okay, so just like yesterday, we were given a partial XY chart, right? And A sub n chart, input, output, whatever. And they gave us some information. It's already filled in here. And they want us to find the domain and the range. Okay, domain is all the x values. Range is all the y values. We can do the domain. That's easy, right? That's all filled in for us. And the range is started. We've got 144, but we've got some missing numbers. So back in example 8 above, how did we find our R? Well, we had 2 consecutive numbers. Remember, if we have consecutive numbers, we can do our little test in reverse. But we don't have any consecutive numbers we don't have any consecutive numbers in this one. Yesterday's problem, we talked about how, and I keep going back to it because I really want you to get the comparison, is we had 2 points. We had like this point and this point. If this was arithmetic, we could find the slope because slope and d are the same thing. But this is not a linear equation. It doesn't have a slope, okay? So we can't do that. But there is something else we learned this week that can help us find something that we need. Oh, yeah. Do you have your notes? Oh, I'm sorry. I didn't see that. I'm sorry, Steve. Looked like you were just sleeping. I can't see your stuff. Does anybody remember what we can do? Something we do? Yeah, what ones? Yep. So geometric mean. Good job. Geometric mean. We have a formula, geometric mean, that we can take the square root of the product of 2 numbers as long as there's a middle, right? So we can find this number by doing that. Or remember we had ones in our homework the other day where we had this number, we had this number. We could find the geometric mean of these 2, and that would give us this one right here, the dead center. And then we could do the mean of those 2 to get that one, the mean of those 2 to get that one. So that's what the geometric mean is good for, okay? So 144 times 36 under the radical is 72, okay? So this is 72. How does that help me? Well, now I can do my ratio test. 72 divided by 144 will get me the same number that I am multiplying by left to right, which is, again, 1/2. Right? So multiplying something by 1/2 divides it in 2. So let's just go through and do that. And so we get a lot of fractions in exponential functions. So I want to talk about the calculator real quick. So when I get to this number and I have to divide it by 2, let's leave it in fraction form. So math enter, enter. So that's how they got, nope, what did I do? 3 times 1/2. What? What am I doing? Oh my gosh. So sorry. Oh, I'm recording this too. Whoever's watching this. Sorry. Okay, sorry. So, right, 36 divided by 2. What did I have there? 6? I didn't square root. Okay, 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 2, I think that makes sense that it's 9/2. But what's really nice, and I noticed that since I've updated all of your calculators, once I change it to a fraction and I keep going with it, it keeps it in fraction mode. I don't have to keep changing it, math enter, enter. So I have to divide that by 2 or multiply by 1/2, whatever. But notice it's going to keep it in fraction form. So 9/4. Okay, so that's how we get those numbers. And so you can easily finish the range here. So using this information, let's write an exponential function. So exponential function, that's the a and the b, and no subtracting 1. We know b, right? b is the same as r. b and r are the same thing, okay? And a is the same as a sub 0. So we can go backwards in our chart and multiply by 2. I mean, we're dealing with the number 2. We're either dividing by 2 or multiplying by 2. Obviously, we want to be bigger if we're going to the left. So you can do 144 times 2, which is 288. And now we have everything we need to write our equation. No minus 1. No minus 1. Okay. Good. Turn the page. Just like yesterday, we have another one of these. Same exact idea. Graph a vertical XY chart instead of a horizontal. It's still, this is X, this is Y. First term, second term. These are my X values, and they gave us all of them there. We don't have to read the graph. 3, 6, 12, 24, 48, 96, and it keeps going. And just like yesterday, when we're talking about sequences, we use the subscript notation, a sub 1, a sub 2, a sub 3, and so on. A sub n. And when we're talking about algebraic, we use function notation. How you doing, Evan? I know this is a lot for you. You've missed all the lessons on this stuff this week. Okay, and then, so what they want us to do is write it both ways. If you want to write the formula again, go ahead. You don't have to. So subscript notation, that's our arithmetic, geometric notation, right? And function notation is our like algebraic. They mean, oops, that should be an N. They mean the same thing. They mean the same thing. It's just two different ways of writing it. Okay, so for subscript notation, I need the first term. Here she is. I need the R to the N minus 1. So I need to find the R. I'm getting bigger, right? 3, 6, 12. What's happening here? I'm doing 6 divided by 3, which is 2. So I'm multiplying by 2. The numbers are getting bigger. R is 2. Right? Function notation. Okay, I need A. A is my A sub 0. It's my starting amount. Okay, I don't have that, but I can find it, right? I can go backwards to get 0. So if I multiply by 2 to go this way, I would divide by 2 to go the other way. 3 divided by 2 is 3 halves. Okay, so that's 3 halves. The R's are the same as B. R and B are the same thing, so that's what I want you to start really trying to know. And then don't forget, we do not put a minus 1. Okay? All right, let's finish this up with our last example. Any question on example 11? Okay. The powerful explicit formula. Understand, explicit formula, general term formula, general formula, all those interchangeable ways of describing this formula that lets us find the nth term of a sequence. We can jump ahead in line as well. Remember, we found the first 10 yesterday, and then we needed the 200th. This formula does all of that for us. And we know it's geometric, not just because we're in that section, but because it's in that like format. It's geometric. Okay? Find the first 6 terms of this sequence. Now, I could plug a 1 in here. 1 minus 1 is 0. Anything to the 0 power is 1, so 1 half to the 0 power is 1, and 1 times 6 is 6. But I also know that this is a sub 1 because that is a 1. right? If that were a 3, this would be a sub 3. If that was a 10, that would be a sub 10, and we saw that happen yesterday. So our first term is 6. And then our r is 1/2. So I can either keep plugging into the formula 2, 3, 4, 5, 6, or I can just multiply by 1/2. Remember, when you multiply by a fraction, it's going to get smaller. So it's dividing by 2. When I multiply 6 by 1/2, I get 3 halves. So I have 3 halves, and then I'm going to divide by 2 a few more times. And they're all on my screen, so I have 3/4. I did that last one too fast. 3/8 divided by 2 is 3/6. It's 3/16, whatever. 3/16. You can really see a pattern there. Start getting to where you don't have to put it in your calculator. Look at the numerator, look at the denominator. Okay, there's our first 6 terms. Find a sub 0. Somebody besides Luke, no offense, Luke, somebody tell me what a sub 0 is. What is that? I can't hear. I'm so sorry. 12. Yeah. A sub 0 is going this way, right? So it's going to get bigger. Oh. And then write the exponential form. Exponential form, okay, that's a times b to the x or n or whatever. So a sub 0 is what we need, our starting amount. Initial starting is a sub 0. R, we already found, we know it's 1/2, or B, whatever you want to call it. Don't subtract. Okay? All right, that's it for the notes. I'm going to give you what the homework assignment is, and then we're going to do the last 2 right together. Okay, so I'm going to do homework problems with you instead of more notes. It's a Friday. Let's try and get our homework done in class. Like I said, I'm going to do 11 and 12 together, which are your only 2-word problems. And you want to do them with me. Number 12 has something in it that we haven't done since last unit. So get that written down and head over to number 11 and 12, and we will do this. Good? Okay. So, number 11, let's read, because there's just some subtle, really subtle language, like one little word that tells you if something's a sub 0 or a sub 1. And we talked about that yesterday being kind of a tricky part of these types of problems. So it reads, a culture contains 10,000 bacteria initially and increases by 20% every hour. Find a formula for the number n of t of bacteria presented after t hours. What you'll see when you get to the other problems in your homework, it'll say write an exponential function or write an explicit rule. It tells you kind of in the directions which one to use. This one doesn't really say. So technically you could really use either one of the formulas. You could write it as a sequence or algebraically. But let's make life easier. If it's not telling us a certain way to do it, let's try to do the least amount of work, right? And when you hear that word initially, what do you think that is? Is that a sub 0 or a sub 1? That's tricky to know that. What do you guys think? What's your gut feeling? You're right, Aaliyah. A sub 0. Initial. Think about like where you start on a graph. You always start at 0. Initial. It's before anything happens to it, right? Like our barrel yesterday of water, it's the most you can have in it is 45,000. This is the most we're ever going to have. It's not going to be more than that. We can't call it a sub 1. Okay? So a sub 0. If I'm going to call that a sub 0, then I'm using this one. Right? If you wanted to do the other formula, I don't know why you really insist on it, but you could go find a sub 1 and then plug into the geometric one and have the n minus 1, but why do that? Okay, so f of n is our 10,000. That's what we start with, our starting amount. And then 20%, remember, just as a reminder, I know we're in a geometric sequence section, so we know this is geometric, but anytime you see a percent sign mixed in with other problems, you know that this is geometric. And we always change percents to decimals in any math problem. I can't think of a time you would ever keep the percent sign in it. But remember, sometimes you have to subtract it from 100% or add it to 100%. And this is increasing, so we're going to add 100% to that, or 1. So it's 1.20 to the n power. Oh, I changed the letters. It said to use n of t. Technically, I should have used n of t, but I would not mark that wrong. Okay, so just so you know, probably should have done that. But it means the same thing. That's why we have to be comfortable with using all these different letters. Okay, so there's my equation. How many bacteria are in the culture after 10 hours? I think we all would agree. N is 10. And we go to our calculator. So 1.2 to the 10th power times 10,000. And if it doesn't tell us what to round to, let's get in the habit of rounding to 3 decimal places, because that's what the AP exam asks. So after 10 hours, we'd have that many. Does our answer make sense? Yeah, it's bigger. So remember I told you the other day I didn't take the time to show you because you were kind of pressed for time. But if I forget the 1, so if I use just the 0.2, which happens all the time, students always forget about that 100% that you have to think about, let me just show you, 10,000 times 0.2 to the power of 10, I get an answer that's less than 1. So if I just use 20%, my answer makes no sense. How do I go from 10,000, I'm increasing, and I have less than 1 now? So always look at your answer. You can catch mistakes sometimes if it doesn't make sense. Okay? I'm almost done talking at you. One more. A rubber ball is dropped from a height of 25 feet. The ball bounces to 80% of its previous height with each bounce. So we're going to fill in the table and answer some questions. So these word problems can be tricky. So for some reason we're standing on a ladder or something, 25 feet, the ball is above the ground, and we drop it. Okay, and then it hits the ground and it bounces, of course, less. You guys would picture it. It doesn't keep bouncing to the same height, right? Every time you go, it's going to bounce a little bit. The height will be lower. So do we think 25 feet is a sub 1 or a sub 0? 0. Nothing's happened yet. It's just there. No bounces have happened, right? Because n is your number of bounces. So 0 before we have any bounces is 25. Okay? So you really have to kind of think of the context of the question. A common mistake here would be to put a 25 right here, but it's not the first one. All right? So let's go ahead and set up the equation. It tells us exactly what type to use, too, right here. And then it'll be easier to fill those in. All right? So we'll make our little equation. A sub 0, our starting amount, is 25. And what do we think our B/R would be if it's bouncing to 80%? 0.8. A little bit different wording. Why wouldn't it be 1.8 or 1.2? Because it's going to be less. Think about it. If I had a 1 in front of that, it's going to go higher than 25 feet. That's not going to happen, right? When it bounces, it comes up less. It's going to be smaller numbers as we go, okay? And it's 80% of what it bounced before. So it just goes down by 20% is really what that means, okay? And then we can plug these numbers in our calculator. I already did it for you. Plug a 1 in, plug a 2 in, plug a 3 in, or you can find the first one, which is 20, and multiply it by 0.8 the rest of the way in. So I'm hoping, because I heard several of you say 1.8 on when I asked that question, I'm hoping if you had used that as your R or B, you would have caught that these numbers were getting bigger, and that wouldn't have made sense in the context of the word problem. Okay? All right, what is the height of the ball after 10 bounces? Okay, so we're going to just plug in 10 right in our calculator, and you get approximately 2.64. Up 4, sorry. 2.684. Sorry. 2.684 feet. That was just in my calculator for you. Any questions before we do the last piece of it? When will the ball bounce less than 1 foot high? A couple different ways you could do this. You could keep going in the chart to find when we get to a bounce height, this part of the thing is less than 1. Or I'm going to show you how to do it on your calculator. We've already done it before, another time. It's finding the intersection. And I'll explain why when we are looking at the picture. But just go ahead and clear your RAM. This is really good practice, too, to keep having those skills come up again and again in different assignments. So when it comes time for you to test on this stuff, you interacted with it a couple times. So let's go to the y equals and type in the function. So it's 25.8, and we don't have an n button. Who cares? You can put an x. It's just a variable, right? Any power. And then in the second equation, y equals 1, a horizontal line. Think about what this is going to do. Why are we typing both of those? So when I graph it, there's the exponential function, way over there, and there's my y equals 1, a horizontal line. I can't see it where it intersects. So first thing I need to do is change my window. Which one of these am I going to change? I want to move my window to the right. X max, right? To the right I need to go. How far? I don't know. Try some numbers. I'm putting a 30 in there. If you don't like it, go back and change it. Be comfortable going back and forth. You're not going to hurt anything. You can change your window 100 times. Okay? And now I can see good enough. I mean, I could zero in on it more if I wanted to, and you can play with it if you want to. But understand this. This is a really clever way, actually, is we're going to find the intersection of these two graphs, because that's a clever way of saying y is 1 right there. Y equals 1 right there. What's the x value, which is the height of the bounce? So to calculate that, we go to second calc. This is where we do our 0, our min, our max, but we want the intersection. And even though my picture's not super clear, mine isn't, maybe you played with yours, it's okay. I just have to be above it or below it, and below it. And I'm above it right now. Hit enter. Then use your right arrow button to get to the other side of it. Second curve, yep. Do I want you to guess? Guess, please. And what you see is y is 1, right? So that's the height is 1. How many bounces till we're below that? 14. Does that make sense? X is 14. Our n is 14. Y is 1. So it's basically where did we get to 1? That's at 14 bounces. Oh, wait. So 14.4, I need to think about this. Oh, because we want to be less than this? So it would be the, yes, Turkey is wrong. 15. Really good job, guys. 15 bounces. Yes, you are absolutely right. Think about it. Those real-world problems, you really do have to kind of think about them, right? So less than 1, because this is when y is exactly 1, and it said less than, not equal to. Okay? But yeah, 15 for either of those. Okay, good. All right, so now you can go back and do the other problems, which are not word problems. They're kind of like what we did in homework. You need help? Oh, yeah. Okay, and I think I can fit the whole sheet up here. Live on the edge. Go without a path. Aaliyah has it.